Lesson is going to be Module 2, Lesson 2. We're going to talk about correlation. Correlation is the concept of, do two sets of data, two things we're measuring, do they have something in common? Do they have an effect on each other? Does one happen at the same time as the other one? So we are going to be deciding if data sets have correlation. Is there a correlation coefficient? And that's where we do some linear regression on Desmos, and we get a value, and we look at it and decide, does it show a strong relationship, yes or not, yes or no? We're also going to look at causation. Does one cause another? And we're going to look at doing some more linear regression practice. So if you guys will go to, let's see, we're starting on page 165. We're going to go ahead and page 166, and we're going to look at some different scatter plots. Now, guys, when you're looking at a scatter plot, if there appears to be some sort of a pattern, then one could say that there is some kind of a line of best fit and there is some kind of correlation, okay? Correlation does not mean causation. It simply means that two things are occurring and appear to be happening at the same time. If I look at this first data set, set A, looks to me like I could draw a pretty reasonable line of best fit. If you look at it, it looks like as the weight of the vehicle gets higher, it gets less miles per gallon. I start up here with a low weight vehicle, a low X value, but it has a very high miles per gallon. Versus over here at the end, I have a very heavy vehicle and it gets a very low miles per gallon. So that is it looks like we have what we call a negative correlation. Think about when we learned about lines and we learned about if they have a positive slope or a negative slope. This one does appear to go in kind of a line pattern, and there is a negative correlation, meaning as the weight gets higher, the miles per gallon gets lower. So think about that. Somebody who drives a little bitty tiny car gets probably pretty good gas mileage versus somebody who's driving a great big 1-ton truck maybe only gets 10 to 15 miles per gallon. Somebody who's got a little bitty car might get 40 miles to the gallon. Okay, letter B does not look to me like there is any correlation between somebody's IQ score, which is a test that measures intelligence, and their height. So it doesn't matter whether you're short or tall. Some people have lower intelligence. Some people have higher intelligence. So I don't see any correlation. I'm going to say there's none there. I can't really draw a line there. Okay, and my last one, it does look like I could draw a line through this data. And let's look at what they're measuring. We're measuring the time spent studying and our grades. Well, one would think that it kind of makes sense that the more time you spend studying, hopefully the higher your test grades would be. So one would think that there probably is a positive correlation. This is a positive relationship. Versus this one up here, again, look like a negative slope, a negative relationship. So as one gets bigger, one gets smaller. The second or the third one, as one gets bigger, the other one also gets bigger. Okay, the correlation coefficient is something that we're going to let Desmos calculate for us. A correlation coefficient is going to be some number, and it's going to be between -1 and +1. Here is what I want you to know. If you're at -1, there is a very strong correlation, but it is called a strong negative correlation. If you're at +1, it is called a strong positive correlation. And if you're really close to 0, kind of like those IQ scores up there, probably would have close to a 0 correlation. They don't have much of a relationship at all. So basically you can look at the slope. When I look at A, it looks to me like if I was guessing and I tried to draw a line of best fit, I think there's going to be a line of best fit. I can kind of draw a straight line in there. I didn't do a super job, but it does look like it's going downhill. And it looks like those dots are clustered very close to my line. I probably could have done a better job on that line. I'm going to do that now, actually. I'll do a better job on my line. I'm going to move it a little bit. Well, trying to move it. That's a little bit, well, okay. That looks a little bit better anyway. Okay, so it looks like a pretty clumped, pretty well clustered around. So I would say, yes, there does look to be a pretty strong correlation. But ladies and gentlemen, if it looks like it's sloping downhill, this is going to be a strong negative correlation. So when I look at my possible answer choices, don't pick a positive correlation. It doesn't have a positive correlation. It has a negative correlation. Now, these two numbers, which one of these is closer to -1? -0.9 or -0.09? Think of this as -9/100ths, -9/10ths. -9/10ths is a whole lot closer to -1 than -9/100. So this would be a reasonable correlation coefficient. And again, we're going to have Desmos actually calculate that for us shortly. So this next one, it's not quite as tightly clustered. Can you guys see that? It's not quite as tightly clustered around a line. But notice that it looks like it's positive. If you write your name on that line, it's going uphill. So it does look to me like as X gets bigger, Y also gets bigger. That's what makes it positive. And it's reasonably strong. Well, 3 of these answer choices are negative. So it has to be my correlation coefficient R equals 0.7. Okay. So the closer you are to 1, the better the correlation. Now, letter C, that's a hot mess. I don't see that I could draw a line anywhere in the middle of that. I can't tell if it's supposed to be positive or negative. It's just a mess. So I want you to look at this. R equals 1 would be a strong positive. Well, this isn't strong at all, okay? 0.5 and -0.5, one of those would be like kind of a not great, middle of the road, sort of related, not necessarily a strong relationship. And that could be going up or going down. Or you could say that you have a very weak to none, okay? Guys, this is the one we want to go with. We want to pick the one that says weak to none. I can't make a prediction. When X is 8, I have no idea what Y is going to be because those dots are all over the place. Okay? Now, there is a crazy formula that one day, if you ever take a statistics class, you'll probably have to do. But we don't have to do this. We're going to use technology. So on my next step, I'm going to go over to Desmos. This is why I have Desmos open. And just like we did in lesson 1, we are going to use technology to come up with a line of best fit. Now, we've only got 3 points. So I'm going to hit the plus and add a table, and I'm going to put in X is -3, Y is -3. I'm going to put in X is 1, Y is 2. And I'm going to put in X is 3, Y is 4. Now is the part where I ask the computer to give me the linear equation, but this is also where I'm going to get my correlation coefficient. So I hit the little correlation, I hit the regression button, and guys, what we're looking for is the R. The R is your correlation coefficient. Now you might notice there is an R squared and there is an R. We just want the R. So it is 0.9986. Guys, that is really close to 1. Also, go look over at your graph. Do you see how close those dots are to my line? This is a very strong positive correlation. It's almost perfect. It is almost a perfectly straight line. Also, just like yesterday, we got an equation. My equation is about Y equals 1.2x plus about 0.6. That was the equation it wrote for the line of best fit, if I rounded it off. Okay, 2.2, is it linear? So we're going to look at a group of friends who completed a survey about their monthly income and how much they pay for rent each month. Now, I don't know about y'all, but I would think the more money somebody makes, the nicer place they could afford to live in. So probably the more money you make, people live in more expensive housing would be my guess. But you could have some people who make a lot of money and are really cheap and don't want to waste their money on rent. So we're going to first identify the independent and dependent variables in this problem. Well, our independent is going to be our X value, and that is going to be how much money somebody makes. There is your independent. My dependent is going to be my Y value. So what I live in, how much money I spend on rent, depends on how much money I make every month. That's what we're trying to see if this really is, if there really is a correlation here. So I've identified my independent and my dependent. We are going to skip the part about the scatter plot, and we're going to go straight, just for time purposes, we're going to go straight to the linear regression. So, and it'll graph it for us anyway in Desmos. So I'm going to let you skip this part, and we're going to go straight to linear regression because we can. So we're going to add our table, and I'm going to go put in every piece of data. So the person who makes $1,400 is paying $450. Person who's making $1,550 is paying $505. The person who makes $2,000 is paying $545. The person who makes $2,600, oops, got a little crazy there. $2,600 is paying $715. The person who makes $3,000 is paying $930. And the person who makes $3,400 is paying $1,000. Now I'm going to zoom out on my graph, and I mean it's going to be way out there because these are big numbers, right? Ah, there they are. Do y'all see that? Wow, that looks kind of aligned, doesn't it? Looks a little bit linear. Does that look like it's kind of linear? So I do think, just based on graphing it on Desmos, I think it's reasonable, and had we put it on that scatter plot on the graph, yes, it does look somewhat linear. It looks positive because the line appears to be going up. So it looks like there might be a positive correlation. Well, we're about to do linear regression and find out if we're right. So let's go ahead and use our technology now, and we're going to go hit the linear regression that looks like a scatter plot right underneath that plus sign. And I've done a linear regression, and let's see. I've got an equation of y equals 0.281531. How about we just call that 0.28 x plus, it looks like 36.27. How about we call that 36.3? Okay, so what that means is for every dollar of rent, multiply every dollar times 0.28 and add 36.3, or excuse me, every dollar of income, you multiply times 0.28 and add 36.3, and that is the line that it's producing for us. But we also want to know what's the correlation coefficient, and we don't have to do it. The computer did it for us. It is 0.98. Guys, that's really close to 1, close to positive 1. That means it is a very strong, and I would say, yes, it is appropriate to use a line to make predictions because this is a strong, and it doesn't matter if it's a strong positive or a strong negative. If you are close to 1 or you are close to -1, you have a very strong relationship, and it's a pretty good predictor for other X values to figure out what the Y value is. So what I want you guys to get out of this is whether R is positive or negative, that's what tells you how strong your relationship is. Close to -1 or close to +1, very strong. If you're somewhere in the middle, closer to 0, like 0.1, 0.2, 0.3, these would be weak. Weak would be 0, 0.1, -0.1, -0.2, +0.2, -0.3, +0.3. Those would all be weak. To be strong, I would say you probably need to be 0.8, 0.9, 1, or -0.8, -0.9, -1. Those would all be pretty strong. That middle stuff or the really low stuff, not strong, okay? Looking at the next page, activity 2.3, We're going to determine a line of regression for the next data set. Again, guys, we're doing the same thing we've been doing. We have our X, which is our independent variable, so apparently time and hours, and Y, the amount of antibiotic in our antibiotic X in your body. Looks like this is a table, and I guess the antibiotic kind of wears off after a while. So this is the table showing how much there is, and we want to see if there's a relationship. So let's add a table, and let's go look and see what our regression line is, and also what our coefficient of correlation is. So 0, 60. I'm going to go put all these in. It's a little tedious, but this is a lot easier than using a graphing calculator. 12, 22, 18. On the next line, 18, 13. What do you see is happening? As your X is getting bigger, what's happening to your Y values? Do you see that they're getting smaller? Okay, that tells me right there, this is going to be a negative relationship if there's any relationship at all. 24, 7.8. 30, 4.7. By the time that 36 hours has passed, I only have 2.8 milligrams of the antibiotic, where I started out with 60. Do you see how much it went down? When I'm at 42 hours, 1.7. By the time I get all the way to 2 days, I'm down to 1 milligram of antibiotic, okay? So let's see what's going to happen here. Let's press our correlation, or excuse me, our regression, and here is the equation that I get. So I have a line of regression, line of best fit, and we'll go look at the graph in just a second. Y equals negative 1.07, and we're just going to chop it off there. X plus 42.3. Okay, I'm going to leave it at that. So let's go look at the picture. Do you see how we have a negative slope? Let me zoom out a little bit. See how it's going down? Zoom in. And it looks like I do have a lot of points clustered around a line. It almost looks like a curve. So I really think this is probably an exponential function, but we're just going to pretend like it's linear. It's going downhill. So is it appropriate to use a line of best fit? That depends. It looks like it's a reasonable predictor, but really and truly, this looks like this is probably exponential. We're going to go look at our R. Our R, our regression, our correlation coefficient is negative 0.8832. So we're going to call it just negative 0.88. That is pretty strong, okay? That is a strong negative. So typically on a STAR test, you would say, yeah, that's a great correlation coefficient. The only reason I'm saying it's probably not for this particular graph is if you look at it up close, y'all can see it starting to curve. And I actually know from past experience, this is actually a exponential. Okay, you guys are going to read the remaining statements and discuss with a partner and decide, are these good, is this correlation versus causation? And let me give you the gist of correlation versus causation. I want you to think about it this way. If you see a bunch of people one day wearing flip-flops, and you also see a bunch of people going to the beach, is flip-flops causing people to go to the beach? Is the beach causing people to wear flip-flops? Or are they just related, but it's not cause and effect? Okay? I would argue that they are related, but it's not because of cause and effect. Because why are people wearing flip-flops? Probably because it's warm outside. Why are people going to the beach? Probably because it's warm outside. So that's probably not causation, but as the temperature goes up, I'm also going to have more people at the beach. That's causation. Okay? As the temperature goes up, I'm going to have more people in flip-flops. That is causation. So correlation, they just happen at the same time. Causation, one specifically caused the other. Okay, you guys are going to finish up this activity on your own.